Well, you've made it. You've made it to day 4. Today we're going to go over CAM, or Computer Aided Manufacture. Hi, my name is Ivan Irons, and I run a website called CNCinformation.com. Let's get started. Well, here's our 5 steps to the CNC process, and you'll see where CAM is located there. It's the third out of the 5. And we'll look at our flowchart again just to kind of give you an idea of where we're at in the process. We're right in the middle of it. So let's get into it. What does CAM stand for? It's Computer Aided Manufacture. And really what it is we're translating our design, that CAD design that we did, into machine code or machine language. Really, we need to know what CNC machine we're going to use, what type of material we're going to use, what are we going to build, but really it's translating that design into something that our CNC machine can understand. Now, our CNC machine, it doesn't really know what we want from it. It doesn't know where the part's located. It doesn't know what tool that we should be using. It doesn't know how fast to move, and we need to define that, and we do that in the CAM step. Here I kind of have a graphic of the various things that we need to do during CAM. Now, not all of these are done every single time, but this is kind of the overview. So we need to define the material, we need to define the stock size, select coordinates, what's our tooling, what's our feeds and speeds. We need to simulate the machining, and then we need a post-process. Now here's kind of a look. This is from Rhino CAM. We'll look at a couple of those steps that I just showed. So right here we're defining on the left the stock, and this could be easily a cylinder as well, but you need to tell the CNC machine what it's holding, what is the overall shape of the stock. And then on the right, you need to locate the part inside of that stock. You need to tell it where to start. So you'll see the Z alignments at the top and the XY alignments at the northwest corner of that. But we need to let the machine know where the part is. It doesn't have eyes, and we need to describe in a very specific way how we want the machine to move. We also need to define what tool we're going to use, and you'll see that on the left, and there's all sorts of tooling. On the top of that photo, you can see across the top the different types of tooling that you could select in here, but they'll also have different lengths and diameters and how big is the holder, and we need to define all that so the machine doesn't crash the tool into the stock. On the right, you'll see a photograph where we're defining the speed. So one of those speeds is the spindle speed, how fast. This happens to be for a milling machine. So how fast is that, say, end mill turning? How fast are we going to plunge into it? These are all things that the CNC machine needs to know, and we need to define before we go out there. Part of that's just a safety factor as well. Next, I really like to simulate the machining, and you can generally do this in CAM if you have this is a little bit of a higher end program, but most of them have some sort of animation where they'll walk through the tool path so you can see how your machine is going to move. So the photo on the left, it's milling out that center hole in that stock, and you'll see it kind of goes down in a spiral fashion. You see the tool path there. And then the next step on the right is drilling 4 holes. This is actually a part I used on my CNC wood router that I built. And you'll see the order of the drilling of the holes as well in that tool path. Then kind of the finale of CAM is you post-process. You define all the different parameters, you tell the machine, you describe everything that you possibly can, but then you need to post-process out a file, and that file will be a G-code file. Well, there's different post-processors, as you'll see here. because there's different CNC machines, and each one is somewhat unique in how it likes to move, and so these post processors make it very flexible. You can spit out G-code for all these different types of machines. So you'll see a number of CNC controllers as well. But you'll see on the right, that one's those are plasma cutter post processors, and the ones on the left are milling machine post processors. So once we post process, we have a file left over, and that file is filled with G-code, which is the language of CNC. It's what a CNC machine runs on. And G-code is the outcome of the post-processing and the outcome of the CAM process. It's what we're left over with when we're done. Now, G-code is not dynamic, and let me explain that a little bit more. It's very static. Once you post-process and you have a G-code file, that file can only do one thing. It's a specific set of instructions. If you go back and change your CAD design and make it bigger, that G-code will no longer build the same part that you want it to. It's not flexible, it doesn't move with it. Same thing with CAM. If you change CAM parameters like feeds and speeds, that sort of thing, you will need to post-process again and create a new G-code file. So G-code is very static. It's a point in time, and if you change things upstream, you'll need to make another G-code file. And we'll just take a quick look at an example of one. You'll see on the left-hand side, those are the numbers. Some post-processors spit them out, others don't. I like it just to keep track of it. And this is, keep in mind, a very small snippet of G-code. But as you read through it and you get used to G-code, the more and more you see it, it's telling the machine to do very specific things. So the first movement on line N01, it's telling it to move in the positive Z direction. So it moves up 1/4 of an inch there. It turns on, you go down a few more lines, it turns on the spindle of the milling machine, and it turns it on in a forward direction, and it turns it on at 1,000 RPM. So it's telling it very specific things. The next line, the N05, it's moving in the XY direction to that location, and then it moves up in a Z, and then it goes in at a certain feed rate. So each of these lines of code are telling your CNC machine to move in a very particular way. So since we're doing CAM today, I thought I'd talk a little bit about the different CAM software packages out there. Similar to CAD, there's 2D, 2.5D, 3D, and you get into a 4th axis and a 5th axis, and this really depends on your CNC machine if it has those abilities. But it usually is an add-on to CAM software programs. And again, with CAM, there's free ones out there, and you can spend out to about infinity if you want. And what I've kind of found is the dollar amount that you spend really depends on the number of axes that you get with the CAM software. So the less axes, if it's 2D, that CAM seems to be on the inexpensive end. If you want 5 axis, well, get ready to get out your wallet, you're probably going to pay. And then I just have a quick listing there of some various CAM software packages: RhinoCam, MasterCam, SheetCam, ArtCam. Those are all pretty familiar ones you'll see on the market. That's it for CAM. Tomorrow we go over CNC machine control. So that G-code that we post-processed, we're now going to take that out, use a control software, and then after that, the final step of machining. But in the meantime, if you have any questions at all, you can go to cncinformation.com and get some more information. Or you'll also see the address to my blog, which is kind of the current things going on in CNC. Thanks.